Okay, completing the square is the process to go from the standard form of a quadratic to the vertex form. So we have a function notation here, and we'll say this was a word problem, and maybe they were saying that t, which sometimes represents our x, is the independent variable, and this is probably representing, oh, I don't know, like the flight trajectory of something. Probably like a ball or a rocket, right? It's a ball, right? So time is our x-axis going this way, and h at t is technically our y-axis. So how high it gets at a certain point in time. Okay, so maybe they're asking what is the max? Probably what the question asked is, what's the max? And to find the max, well, we're looking for the vertex then. The vertex is really, really important. They might, hey, what's the max and what's the time, or how long does it take to get to your max? So we're going to go through a process called completing the square. And when we go through completing the square, so get them. We focus on the very first two terms. Okay, so the very first two terms, I'm just going to highlight them. We're actually going to divide both of them by the a coefficient. So if you remember in standard form, there we go. Let's say this was y. When we write standard form, we write a at x squared plus b at x. Sure, we'll get them in a sec. Plus c. What we're going to do is we're actually going to divide these first two terms. I can even put like a set of brackets around it. We're going to divide them both by a. It's known as common factoring. We're going to common factor out the a of them. Okay. So in this case, it's -5. So we're going to common factor out -5. So all that means is on the next line, we have a coefficient in front of the bracket of -5, and then whatever's left over goes inside of here. Okay, so that -5, I didn't write it very cleanly here. I'll rewrite it for us. We have -5 because that was the a value, and then we divide. So in -5t divided by -5 is actually just 1t, and we don't really need the 1. So I'm just going to write the letter t, and that's the goal. We actually want to get whatever the first variable is by itself completely.
Oh, sorry, it's like it's.
Sorry, 100% right. Yeah, it is squared. Sorry, I didn't write that in. Okay. And finally, 10 divided -5 is actually going to be -2t. Okay. The 1 or the c value still stays the same over there. So the next thing we're going to do is we're going to complete. We're going to create a perfect square trinomial. That's actually the point of doing this first little step. So we have -5t squared minus 2t, and we're actually going to get two terms here. We want to put two more terms in this bracket. We want to put a positive and a negative of a term. How do we know which term to use? Well, we're going to take this -2t, and specifically we're going to do the coefficient in front of it. So -2, we're going to take -2. There we go. -2 divided by 2 squared. And really what's happening here is we take the new b value, so I'm going to say this is the new b value, you divide it by 2 and you square it. Okay, that's the idea here. So in this case, -2 divided by 2 is -1, and -1 squared is just 1. So I'm going to both add and subtract 1. The reason you can add and subtract 1 is because +1 and -1 is 0. So really all we do is add a 0 to this equation.
I do this to the side?
Yeah, I just do it on the side. It's like a little side calculation. I mean, you can do it in your head if you want. I write it on the side just so I have a reference. Okay, but this is the key thing. Whatever the new b value is, you divide it by 2 and then you square it. Okay. The last thing we want to do is the negative term we actually no longer want in the brackets. So the very next step is to actually take this negative outside of the bracket. Okay, so let's go to our next line here. So we get -5 t squared minus 2t plus 1. And now this -1, when it comes outside the bracket, it actually had to be multiplied by this value here, by the a value with this -5. Okay, think of it like distributive property. In order to pull it out of the bracket, it actually has to get multiplied here. So -1 times -5 is actually going to be +5. Okay, and that +5 can be simplified with that +1 now. Oh, I forgot there should be a 1 here. Okay, so we pulled that negative 1 out, and when we pulled the negative 1 out, we multiplied by, we took this negative 1 out, and multiplied by the a, okay? And that's how we got positive 5 here. Great. Let's simplify these terms on the outside to make our life a little easier. We get negative 5, t squared minus 2t plus 1. This becomes plus 6. Now, the final thing here is this is called, that whole process above was to create a very specific type of quadratic. It's a type of quadratic that factors very simply. In fact, what happens is the two brackets, whatever you factor, they end up being the same. So I'm going to say, for example, it's going to be like x plus 2 and x plus 2, which means we just get x plus 2 squared. Okay? It's called a perfect square trinomial. That's what that whole dividing by a, adding and subtracting of a term, dividing by b, that whole point is to make this really special quadratic. So instead of going to factoring like we normally do, because we know it's a very special quadratic, we can skip to the answer really quickly. In fact, all we have to do is we're going to take this first term, we're going to square root it, so square root of t squared, and we're going to take this last term and square root it, square root of 1, and those two values, square root of t squared is t, square root of 1 is 1, those are going to be the two terms in the brackets. Okay? So we're going to get t, and we're going to get 1, and whatever the operation is in front of the b, in this case it's negative, that's going to be the operation in the bracket. I then write a squared plus 6, and this is my vertex form. Okay, so we take a look at it just a little more closely. So our vertex form is negative 5 t minus 1 squared plus 6. What does this tell us about a vertex? Well, this is the x value of the vertex. The x value of the vertex is actually going to be at positive 1, and the y value of the vertex is at positive 6. So we know the height of the ball was 6, and it was at 1 minute, second. I have no idea what the time unit was.
Why is it in positive 1 now?
It's always the opposite of what's in our bracket for vertex.
So then only the one in the bracket, not the 6?
Not the 6, yeah, not the 6. So let's say you were using that formula to find the vertex form. Remember we talked about the formula? You would like reverse it when you put it in the brackets. It's similar to when you have, you're doing roots. So if it was like x plus 3 and x minus 2, those are actually opposites. If we were going to write the roots here, it would be negative 3 and positive 2 would be like the roots of this quadratic, okay? So it's kind of a flip in terms of pulling it out, okay? Another way you could think of this one, and I know it's not for every case, but in this case, because we're measuring time, we don't ever go back in time. We would never say the highest it could be was a second before I threw it. That would literally make, not literally, but it would not make sense. If I were to tell you that this is the highest point of the quadratic, well, we're not going backwards. Time always moves forward. So we know that time must be at the positive value. It must be 1 unit after I threw it.
How did, like...
And the other one here, t squared. So, t squared is the same as writing, so if I write t squared, it's the same as writing t times t. Just like if I was finding the square root of 25, well that is I can substitute 25 as just 5 times 5, right? And we only, when we're finding square roots, we only need the one value. We're saying two numbers together multiplied to something. So the two values here, we know that that's going to be 5, like the square root of 25 is 5. So the square root of t squared is just going to be the letter t. Think of it like the square root and this power, they cancel each other out.
Do you do these two numbers? Like
Yeah, you just do the first number in the bracket.
Yeah.
First number and the last number, we square root those, and we bring down the negative in between. Okay, so we had a negative there, that goes in between here, and that's it. It's a really specific process, lots of little intricate things to remember. So that formula we have is really good for checking this. It'll check like our 3 terms, our A, they usually call this the H term, and they usually call this the K. So if this was our vertex form, it's usually written, we have A, they write x minus, and that's why they also have the minus here in like the parent function they call it. Actually, I think do I usually write that in blue? I think I do. And then the k is out here.
So,